So in this video, I'm going to be using Pythagorean theorem to determine the length of side of angle 30, 60, 90 right triangle. Now, for us to be able to achieve this, we would have to use an equilateral triangle with length of side 2x units, right? So let me draw an equilateral triangle. Okay, so permit me to use my ruler. So let's say we have this like this, we have this like this. Okay, so I'm trying to draw it. So pardon me, this is my equilateral. This side, and this side are of equal length. So now we are using the length of side 2x unit. So this is 2x, excuse me, this is what 2x. Let me use this. So 2x, this is what 2x, and this full length is what 2x. So and for an equilateral triangle, each of the interior angle is 60 degrees. So definitely this is 60, this is also 60, and this side is also a 60 degree. So what we're going to be doing is we're going to be bisecting this triangle. So if we bisect it, we're going to be drawing a perpendicular bisector of this triangle. So if we bisect it, what does that suggest? It implies that this internal angle will now reduce to what 30 degree each. So this will now be, so this one will be what 30, and this one will also be what 30 degree. And of course, this is 2x. If you divide it by 2, this will now be what x, or 1x. This is x. So in order not to make it complicated, so we can decide to, don't forget that this is a perpendicular bisector. So definitely what I'm trying to say is that this is 90 and this is 90. So let me label, let me say this is A, B, C, and what D. So we can actually use ABD, and we can use what BCD. So to actually get, of course I've gotten my 60, 30, 30 and 90. Okay, I think 30 can enter this place too, but don't worry. So let's just pick any of the triangles. So from triangle what? From triangle AB what D. So that's what I want to use now. So there's only one side that is missing, that is the what? The length of this side. So if I draw that triangle, the triangle will look like this. Okay, so this is ABD. So this is the triangle. All right, so in that case, this is still what 2x, and this angle is what 60 degree. Don't forget that this angle is now 30 degree because it has been bisected. So I still have my A, I have my B, I have my what D, and so this is x. So I need the length BD. So to get the length BD, what do? I use what? Pythagorean theorem. And Pythagorean theorem tells us that the square of the hypotenuse is equal to the sum of the square of the other two sides. Hypotenuse in this case is the side facing the right angle, which is what? AB. So we can see that what AB square will now be what? BD what? BD square plus what? Plus AD what? AD square. So what is AB square? AB square is what? 2x right square is equal to what? BD. What is BD? That's what we are looking for. BD what? Square plus AD square. That is what? X square. So 2x square basically will now be equal to what? 4 what? X square will now be equal to BD what? BD square plus what? X square. So if we bring this inside, we are going to be having 4 what? X square minus what? X square is equal to what? B what? BD square. So 4x square minus x square, that is what? 3x square is equal to what? B what? BD what? Square. So we can say that what? BD square is equal to what? 3 what? X square. So the next thing we do is to take the square root of both sides. So we have BD will now be what? Square root of 3 what? X square. So if you decompose this, this will give us square root of what? 3 multiplied by square root of what? X square. This cancel this. So this will give us what? X root what? 3. So what you're going to be having here is what? X root what? 3. So what is the significance of what I have done here? Perhaps somebody may be asking that. Well, I can use SOHCAHTOA, Now, the significance is that in your SAT or GRE exam, you won't be allowed to use a scientific calculator, especially if you are thinking of using SOHCAHTOA. So if you don't understand this, figure, you may not be able to solve any problem relating to this. And there's another thing I want you to know, is that from what I have done here, the side facing 30 degrees X, the side facing 60 degrees X root 3, because in GRE specifically and some SAT problem, they can interchange this, whereby they will put 60 here and they will put 30 here. So if you are going to be establishing a relationship by comparing those triangles, you have to be very smart to know that the side facing 30 degrees X and the side facing 60 degrees, X root 3. Another thing is that the triangle may not be in this form. So let me produce it. The triangle may actually be this other side. So if I produce this, will be like, excuse me, let me use my ruler to be like this. So if it be like this, it doesn't change what I have done. This is still what? 90 degree. This will be 30 degree. This will be what? 60 degree. So the hypotenuse is still 2x. Then the side facing 30 degree is still what? X. And the side facing 60 degree is what? X root 3. So perhaps somebody is asking now, okay, let's apply what we did. In the previous video, I for 45 by 45, I showed an example. So now let's now apply this particular one. Let's look at how we can apply it in solving, problem. So in this case, you have a triangle. Let me draw a triangle. Let's say we have a triangle like this. Okay, let me still draw it. Look at this triangle now. Right? So you have a triangle like this. So in this triangle here, we're given that this is 60 degree. And we're given that this is Y. We're given that this is X. And we're given that this is what? 3. And so for me to be able to solve this, obviously if this is 60 and of course this is 90, this definitely will be what? 30 degree. So all I'll just do is I'll recall my standard triangle. And my standard triangle is like this. All right, this is my standard triangle. I think I should remember it offhand. This is what? This is 90, this is 60. So this is 2x. This is x, and this is what? X root what? 3. So definitely this is what? 30. So how do I solve this problem? All I'll do is to equate their coefficient. X is x here. So we can equate the hypotenuse and hypotenuse. So we can equate this side and this side. So it is easier because this gets actually has what we are looking for. So this is 3, this is x root 3. So you can say that what? 3 is equal to what? X what? Root 3. Because basically what we are looking for here is we are looking for x and y. Looking for x and y. So let's note that. So in that case, we have 3 is equal to x root 3. And if I make x the subject of formula, I have what? X will now be what? 3 over root 3. Now let me make something clear. This is a good answer, but we need to rationalize it. So by rationalizing, we multiply by root 3 over root 3. So you can check my video on rationalization of sort for further explanation on how to rationalize radicals. So 3 times root 3, that will give us 3 roots what? 3 over root 3 times root 3, that is 3. How? Root 3 times root 3 is root 9, and 9 is a perfect square, and square root of 9 is 3. So this cancels this. So the final answer is what? Root what? 3. What does that imply? It implies that 3 over root 3 is the same thing as root 3. So somebody will say, now how come? So press it on your calculator. 3 divided by what? Root 3. That will give you 1.732 whatever. Then root 3 is also 1.7320. So that is that. So we've gotten the value of x. Having gotten the value of x, we need the value of y. And what is y? Y is what? 2x if you equate it. So we have that y we have that y is equal to what? 2x. So therefore, we can say that y is equal to what? 2 times what is x? That is what? Root 3. And that will give us what? 2 what? Root 3. I want to believe this video has helped someone. The reason is I needed to show you what the significance of that particular proof I've done so that you can understand better. Please kindly subscribe to this channel, like, share, and please do the needful thing and comment. So thank you for watching this video. See you in the next video. Bye.